In this video, I'm briefly going to go through how to determine the area of a circular sector, at least an area of a sector of a circle that has a central angle theta and a radius r. And those would be the only two measurements we actually indeed need to know in order to find the area of a sector. And just really to be clear on this, what I mean by the area of a sector is this. I want to find the area. Let's see if I can kind of sketch this in here. We say really what I want to do is maybe find the area of just this piece of a circle here. We call this a circular sector or a circular sector area. Okay, so just to kind of lay this on you without deriving the formula, what I can tell you is this. It says for a circle of radius r, the area A of a sector of a circle with a central angle theta is defined by this. We say that, if you can't read this very carefully, we say that it's 1/2 r squared theta. I've also seen this written as 1/2 theta r squared. So I always, and this is just kind of a side note, but we say S equals theta r. If you're talking about arc length, that's related to this formula, not in terms of how you find it, but in terms of how you might remember it, in that they both have a theta and an r. It's just that the area formula has a half in front of it as a coefficient, and that the r value is squared. Of course, we're talking about a two-dimensional measurement here, something that has length and width. So let's go ahead and try this out here. One thing I will mention though before we start is this. Theta needs to be measured in radians, and that's actually listed here in this definition. So our first example here, if we read through this, it says a sprinkler on a golf course is set to spray water over a distance of 75 feet and rotates through an angle of 135 degrees. It says find the area of the fairway that's being watered by the sprinkler. You'll notice that our angle measurement here, let's go ahead and write this down, was given to us in degrees, which is just no good. Actually, I don't have much problem with it, many problems with degrees, but I do have a preference that we do things in radians, and actually sometimes it's necessary, like thusly. So, or like this problem. So what we need to do first is this. Before we go ahead and throw this into our area formula, which is 1/2 angle times radius squared, we need to go convert this 135 degrees into radians. So let's go ahead and multiply it by our conversion factor here, which is when going into radians, pi over 180 degrees. So our degrees kick out. 180 and 135. You know what? Actually, I noticed that both of these are multiples of 45. They're multiples of 45 degree angles. So if I said how many times would 45 fit into 135, well, that's 3 45 degree angles, and 45 would fit into 184 times. Now, of course, you could have reduced those by a factor of 5, and then I think by maybe a factor of 9. I could be wrong, but here's the deal. You could actually run through and reduce those piecewise, or just do it all up front. So we'd say, well, oops. Sorry. We say that, yes, 180 degrees, the degrees kick out. What I meant to say was this. 45 fits into 135, not 45 times. I was thinking 45. 45 fits into 135 3 times, and 45 goes into 184 times. So as far as our angle in radians goes, we have 3 times pi on top, so we have 3 pi, and then we say 1 times 4 on bottom, or 3 pi fourths. So of course, yeah, when one considers this, 3 pi fourths, that would be a pi fourth, pi fourth, pi fourth. 135 degrees, yes, is the same thing as 3 pi fourths. But we do have our angle now, so let's go ahead and substitute these values. We say 3 pi fourths times 75, and this is important. We put our units in here, feet squared. So we may need a calculator to help us for some of this, but we say in terms of an exact value, let's go ahead and multiply some of this stuff straight across. We say 1 times 3 pi would be 3 pi, 2 times 4 would be 8, and now we could take 3 pi eighths times 75 squared. Now, last time I checked, I don't know the square of 75 off the top of my head, so let's go ahead and find this here. We say 75, that squared is 5625, and so we get 5625. I'm going to put this over 1, but this is now square feet. We actually squared the units as well, and so multiplying this straight across, I'm not sure, do they share any common factors? Suppose we could figure this out when we're done, but for right now, let's go ahead and multiply these things straight across. We have on top 3 times pi times 5625. So 5625 times 3 is going to be 16875. So we have 16875 pi, and this is all over 8, and this is in square feet. So now, this being our exact value, we probably want to get a decimal approximation as well. So let's go ahead and take this 16875 times pi. We have a pi upstairs. We get this value here, and we're going to go ahead and divide this by 8. What we determine is approximately 6626 we'll go with an 8 here. So 6626.8-ish, and this would be feet squared-ish. Okay, but that's how you use your formula for an area of a sector to find the area of a sector of a circle. Cheers.